Yeah. Uh, Once again, good morning, everyone. Thanks for having a patience. We have a excellent number of attendees today for our today's webinar. So um, uh, let's. I'll again welcome you all from the behalf of Best Engine Aids and Consultancy. Myself, Piyush Turi. I look after the simulation product portfolio here in Best Engineering Aids and Consultancy, that is short form as Beacon. Okay, so whoever is new to the GoToWebinar user interface, so this is what GoToWebinar looks like. If you have any particular questions, even let's say in between while we are going to the webinars or even at the last of the webinar, feel free to write a question in the question mark option present on the right side of your task menu. We'll address those questions at the end of the webinar. So my colleagues will help me out to uh, probably read those particular questions and help me to how we can address them either today or probably after certain days. So yeah, once again, the today's topic is something where we are going to understand how we can do a dynamic and fatigue-free design for an industrial equipment. So the agenda is very sweet and short. We are going to understand what are the current challenges the industrial design or industrial equipment industry faces. What are the current trends in that particular area? We have something called as a MODSIM journey of a RESEMIN. So we'll introduce you what is the RESEMIN first, and of course the MODSIM term. Probably some of you may be familiar with it, but as I understand, most of you may not be knowing what is MODSIM. So we'll also introduce what is MODSIM here, and then we'll see how the presentation, what are the key takeaways from this particular presentation. So let's start by understanding what are the industrial challenges and trends here. So industrial challenges are different to different for various industry, but what we have for industrial equipment is what you can see on the screen, like product failure and warranty. Probably you may not be familiar, but almost I can say 2% of the revenue that this particular industry gains is actually being utilized for reclaim of the warranty as well as the product failure, that comes around in a range of around $2 billion. So the loss, probably it's not a big, but yeah, but it's a very thing which we need to focus on to understand how this can be not totally neglected, but yes, reduced to a certain limit. Since the industrial design have a very complex design in the market, so the design complex being a very competitive market in the industry, where the design is also complex as well as it's very competitive in nature. Since the design is very complex in nature, the manufacturing of that particular product or to produce a mass level of production is also very big critical for this particular area. One of the biggest challenge they have is something called as a skilled labor. So it can be on ground or even at the design level, where let's say if I talk about on the design level to perform such simulation, a skilled labor is needed. But this is something we as a beacon or we as a Dassault systems are there for you to address those particular challenges. So let's understand what is MODSIM and what is how we can utilize this MODSIM environment using the RESEMIN. So first, let's quickly understand what is RESEMIN. So RESEMIN is one of our customer of SolidWorks. It is based out of Peru, and it's been in the market from 1989. It has been making lot of machines for digging, boring, and all application area. Since those application area has lot of vibration, lot of repetitive cyclic loading, the challenges are something unique or repetitive for them. Let's understand what are the challenges for them. So to understand the challenge, here is a quick video of a testing setup what they use in their particular application area. So this is the actual RESEMIN boom assembly with a drill machine here. So you can see how the drilling is has been started. While drilling process, there are of course lot of vibration that is going to get back to the machine from the source, and of course those is going to cause me a fatigue, probably not a sudden, but after a certain years. So due to the cyclic loading, the field failures are happening a lot. Like here are some example of the actual machine where you can see the area where the failures had happened after a certain time or after due to the cyclic loading. So due to this, they are losing lot of revenue to provide to the customer who are they're serving to. Like they provide a particular period of warranty, but inside the warranty only the product start getting failed at certain location. So another thing, what they have recently want to address is something with respect to the that is a we call it as a ROPS or even a FOPS, that is falling object protective structure or rollover protecting structure. So this is something what they wanted to understand how this can be done virtually rather than depending on a physical prototyping. So here also they utilize some standard, like in this scenario they have used two standards, ISO 3164 as well as ISO 10262. Now let's understand what is MODSIM approach. But before approaching to the MODSIM, let's first understand what is 3D Experience Works. Whoever who is not familiar with 3D Experience Works, so 3D Experience Works is a brand under Dassault System product portfolio. It is the power and breadth of it is one of the power and breadth of a 3D Experience platform. So what is 3D Experience platform? It's actually a collaborative environment for a lot of multiple disciplines and stakeholders. So these disciplines can be anything like design and engineering, simulation. It can be a marketing sales, a person who is handling the data, or even a person who is doing the production as well as the manufacturing work. But our focus for today's webinar, it will be more on the first two part, that is the design and engineering and the simulation. So this together forms a bundle called as a MODSIM, where we introduce a solution which is design centric. Probably a lot of you are SOLIDWORKS users. So this solution brings us to a SOLIDWORKS design centric solution where whatever you design in the SOLIDWORKS, if you want to do a quick update, yes, it is possible in the simulation environment. It is integrated with SolidWorks. It is a design centric where you get a quick assistant tool to help you out to do the particular analysis. It supports multidiscipline or multiphysics analysis. It has a scalable as a comprehensive solution. We'll focus on the last two, that is the on cloud and collaborative in the ongoing presentation, where you can see how we have something very big thing for you rather than just a simulation solution. So let's understand this particular MODSIM journey using the RESEMIN product or the RESEMIN geometry. So here is the quick roadmap that we are going to cover in today's webinar, where we'll understand some unique value of digital transformation, how the data what we create in SolidWorks can be managed using the 3D Experience platform. Same platform, how we can do the validation of it. Let's say if I want to do some changes or democratization, how a designer can do those changes as well as validate at his end rather than dependent on the advanced simulation done by my senior colleagues. And once the design changes has been implemented by designer, how the senior guy can revalidate the same design to check whether the requirement has fulfilled or not. So what is the unique value we have here? So transition from traditional to MODSIM. What do you mean by transition from traditional to MODSIM? Like probably let's understand by quick understand that this is a particular geometry which is like created by one of my designers. So let's say I will take one example where my colleague Vaibhav Dhuri has designed this particular product, and he want to understand whether this can sustain a given load or not. So his focus would be more to do a very basic understanding to understand the given thickness is enough or not. Are the holes that we created for particular mechanism or bolting purpose is going to cause any failure at that location? What is the optimum or iterative design what we can get from here? While my focus as a product engineer would be to do an advanced simulation where I'll take the whole geometry to understand the comprehensive simulation of the whole geometry, or even we talked about something where we want to do a falling object test would come under my bucket to be validated. So how this unique value where 3D Experience SolidWorks or SolidWorks environment can be integrated with this particular simulation solution. So here we are talking about two of the brand of Dassault system again, that is SolidWorks and Simula, which has been integrated inside 3D Experience platform to work collaboratively and do the to do the particular analysis without being a disconnected or working as a silos. So let's understand with one of the example. What we are going to do here, we are going to take an example of the boom assembly of the RESEMIN, and we are going to only focus on how this can be validated inside a 3D Experience platform, which is connected with SolidWorks. So whatever we do, we start with SolidWorks, where you can see we have created a design. We save that design to a centralized, we can say a cloud environment. And this cloud environment is so powerful that it can be accessed by anywhere, anytime, and even by any device. So with the solution, we have something called as a web browser environment where you can access this even on a mobile or even on a iPad. Since it's a flexible license, so licensing also it's very flexible. What you can see on the screen is like a licensing environment where it's based on a login credential. You just need to provide your email ID and login password, and you are able to log in it and do the further part of it. Here you can see an example where I have opened this particular boom assembly in SolidWorks. What I need to do is only to save that assembly using the my session environment, where once I save the data, this data is now available on the simulation environment to do the further work. Like once I save the geometry, I can directly open the geometry even by drag and dropping from the SolidWorks and visualizing the same component. Once the geometry is brought to the environment, the next part comes where I want to set up the analysis. So in any particular simulation software, the validation part is actually divided into three steps: pre-processing, processing, and post-processing. Here also, we have divided our solution into three parts. That is modeling, or we call it as a simulation modeling. Whatever you do in a CAD is a CAD modeling, but in simulation also we need to do some thing called as a simulation modeling, where we need to, if we want to do some what you can say design refinement by removing some small details, creating connections and mesh, comes under the simulation modeling. So here are the steps that comes under simulation, like creating materials or applying the materials, defining the mesh, defining how the components are connected, whether they are bolted, welded, or is there any bearing connection in between them. Those can be defined here. Then comes the scenario creation, where we tell the software what type of analysis I want to perform, whether it is a static analysis, whether it is a dynamic analysis, whether I want to do a modal analysis or a thermal analysis. According to that, what type of loads I want to apply, and as well as the restraints that I want to apply. Where it is fixed, where are the forces are going to apply? Are the force constant, or it is going to vary with respect to time? Last, once you run this analysis, the last part comes the post-processing part, where I want to review the result. So reviewing the result to just to understand whether the required KPIs has been matched, or is there any further scope of improvement. So let's start understanding all the three steps one by one. First, once you brought the assembly in the simulation app, you first start by applying the material. So it comes with the inbuilt material. Again, let's say if you have applied the material at SolidWorks level, you don't need to worry. That material get automatically populated here in this particular environment. So that is how tightly connected the solutions are, like SolidWorks and simulation solutions are connected with each other. Next part comes by creating the mesh. So we have a multiple method in which we can create a mesh here. In this solution, in this current scenario, we're using something called as a user-driven mesh, where uh, I'm restricting my users that in this scenario I'm only going to use the 8 tetrahedron mesh on the whole geometry. Once I create that user-driven mesh thing, I can apply that mesh manually to every component, or there is an option where I can tell the software to use the same user-driven mesh template for remaining part. So what you can see on the current screen is that I'm selecting the mesh rule for the first component, and the same thing can then be replicated for remaining component. Once it is done, I just need to click a run, and what software will do, it will apply those settings for every component, and it will even update the mesh. So here you can see how the mesh is getting updated one by one for every component, and how beautiful the simulation, 3D Explain simulation has captured the mesh for every component. Oh, I forgot to tell one thing. The solution what you're seeing right now with respect to the 3D Explain simulation, it is powered by one of the well-known software in the market called as Abacus. So Abacus and FESAB are the back-end solution or the solvers what 3D Explain simulation use here. Next, we'll start by defining the connectors. So here there are two or three types of connector that we are going to use. First, this boom is going to get bolted on another component which is not being taken into consideration for this analysis. But we don't need to have worry about it, since we have an option where I can bolt a particular component to a ground where I don't need to model a ground separately. Here I have also have an option whether I can apply a preload and do the understanding is the preload is going to cause any challenges or not. There is an option called as bolt replication where I don't need to create each bolt every time. Just create one bolt and software will find out the same bolt replication if it is present inside the geometry. So you can see how software has found out the 11 bolts in the remaining part of the same plate. Next, we have removed the the hydraulic mechanism present here. So what we are going to do here, we are going to replace it with a connector called as a translator, where I can select the geometry which are being connected by the translator mechanism, like in this case the top two faces and the bottom two faces. Since it is oriented at a special case, we can define a local axis to tell the software that it is aligned to a particular degree. Of course, we all can add some additional thing like what is the elasticity of that particular dampers or the damping mechanism, what is the damping coefficient of it. Last, my force is going to be acting at a different height which is again not being modeled here. So we have an option called as a coupling where we can create a remote point and couple it to my geometry, and we can use it for a certain way called as a remote force, where the force application or the line of action of force is somewhere different from the actual geometry present in the tool. Last, you can see like once this is done, you get a single window where you can visualize all the connectors that are being created inside the single assembly. So you don't need to manually find it in a design tree. You can quickly look it here. If you want to make any design changes, delete it, change any particular value, it's possible using this particular connection manager. Last, we'll start by the second step, that is creating a scenario. So this particular tool has something different application where we can use a different app for different products. Like here we are using a mechanical scenario creation app where we can select the existing FEM that we created, define the what type of analysis I want to perform. Like in this case, I'm doing a static step analysis. We can define what is known to us, like whether nonlinear is going to be into picture or not, what is the time step. So it's again a pseudo time step, since we are doing just a static analysis, not any particular inertia effect. We can define contact interaction, how the two components, like we created connectors where the component was connecting to geometries or elements, but in the scenario where the components are interacting directly, we need to define the interaction. So those interaction can be modeled using a tool called as a contact detection. So here we have an option, either we can manually create a contact or we can use a contact detection. The connection property that we created earlier, where we defined some friction coefficient, how the component will interact when they are normal to each other, can be utilized here for defining the contact. Last, we'll create the force and distance. So in this scenario, of course, my geometry is this is not again fixed. You can see I have only defined the 1 degree of freedom to be fixed, that is along X. Since my bolting is going to take the remaining degree of freedom by fixing the bolting equations to the ground. This way we can accurately model the actual boundary condition rather than over defining or over costing my geometry. Apart from that, we'll also go further and define the load. So in this scenario, probably we'll make the coupling visible. And here we can use force or remote force option and I can select that coupling quickly from my design tree connections. On this coupling, let's say if I want to apply any type of load, like in this scenario, I'm adding a bending load, those can be added quickly. Now, let's say I want to also do another study where instead of adding that bending load, I want to add a axial load. So copying the same setup is also very easy. So here we get an option called as a duplicate analysis case, where I can quickly copy the same study and just change the force direction. So here you can see how I quickly copied the study, and now in the new study, what I'm going to do, I'm just going to change the force direction by 45 degree, as well as change the value of the force. We are also going to perform a durability or a fatigue analysis, where I want to understand if this particular load, that is the axial loading case and the bending loading case, how it is going to affect my geometry, or what would be the life of my product, where are the critical area from which my geometry may have the damage for propagation after certain cycles. So durability setup is also very easy, where you can quickly set up a durability analysis case, define the loading condition. Like in this case scenario, we are going to use a superposition method, where we are going to take first of axial loading, as well as we are also going to add the bending loading. We can define the signals, how the signals are, whether it is going to go from 0 to 1, that is axial loading is going to on off, or it is going to go in a negative value also. So once all the three studies are set up, we can go ahead and do the processing part. So processing part is something we have a very beautiful tool called as a HPC, cloud embedded HPC, where you don't need to worry about running the analysis on your local system. So you have an option where you can either run this analysis on a local system using the tokens or using the cores present inside your machines, or you also have option where you can opt it out to run the same analysis up to a certain limit. Like in the structural, it is limited to 8 core free of cost on your cloud. So let's first understand what is cloud and how this can be utilized. So computing landscape, what you can see on ASK, by default, any desktop simulation present in the market provide you with a solution where a basic, let's say 4 to 8 core. If we even talk about SOLIDWORKS simulation, it supports up to single core for solving, but it can go up to multi-core for certain app type physics, like generating context and all. But this is the limit where the core computing is limited to 4 to 8 core or even below that. And since it is running on my system become idle at that time. I cannot do any other thing. It is even if I try to do what may happen, it may get hang, or it may get shut down or something. Alternative to that, 3D Experience Simulia or 3D Experience Simulation provide you an option where you can run the same analysis. If I talk about structures part, 4 to 8 core on your local system, or 4 to 8 core or 8 to 144 core on a cloud. So of course 8 core you can you get it with the software, but let's say if you want to even upscale it to even 144 core, yes, we have something called as a tokens and credits option, where you can upscale the simulation up to 144 cores also. Why core? Well, I'm focusing on core, and every time when we talk about this particular cloud computing, why core is important. So if I go further in this slide, you can see a comparison where it's a very basic example where a person is dropping a camera geometry from a certain height. If I want to solve this particular analysis on a single core, the time to takes for this particular analysis around, I can say around 4,200 seconds on a single core. While the same analysis, if I try to run on a 36 core or even on a 8 core, it is hardly taking around 900 seconds, while on 36 core, it is hardly taking 400 seconds. Another benefit of having a cloud computing is that once you put the analysis run on a cloud, your local system is free to use for any other application. Like you can do any other work, create design, make changes, even open the 3D Experience Simulation app, set up another analysis, put it on a local compute. That is also possible. In the cloud computing, we have a two options like credits and token. It's very basic or very easy to understand. Credits are like consumable entities where you buy it, you use it, and how much you value use it, it will get over. Tokens are something like our SNL or network licensing, where let's say if multiple people are using the tokens, it get consumed for a temporary time. Once the simulation is completed, it is available for next simulation for other user. So once you put it on a cloud, you run the analysis. The next thing comes to review the result. So reviewing the result also in the same environment where the application what open is something called as a physics result explorer, where you can quickly see the result. It may be stress, displacement. You can quickly put a point somewhere to understand the probe value at that particular location. Take a time dependency details like how the stresses are building at that location. Even check the displacement. Like in this scenario, displacement is around 8.26 mm at the tip. To understand where it is, of course, we have option to manually probe it or find out the min max value. Here you can also see the life of the product where we perform a durability analysis. The minimum life, what we have found it here is around 5.86 log of life. Now, my understanding is that this is very much limited. Like I wanted a log of life to be minimum 7 in every area. The given design what we have used is failing. Now, how can I communicate this to my designer that the design what we have created or what we you have given to me doesn't fulfill the cyclic load, or it fails in the given warranty time what we have claimed to be. Now here what we can do a quick requirement check to understand what went wrong. Like my requirement was like the life of the product should be minimum 7 log of life, as well as the stress should be greater than 250 MPa. If you quickly check with the geometry, of course the life is below 7, the minimum life is 5.86, while even the stress plot where at certain location the stress are well above, like it is the maximum stress at certain location is going in a range of 375 MPa. So what we can do here? So here traditionally what we do, if I want to connect to my designer, that is Vaibhav, I need to either write him back, call him, probably take some snap and put it in a WhatsApp or a mail. But that is not a formal way to do a particular communication. So here we have something called as an easy collaboration tool present with our software. So this is what you can see on a web browser. I can see my name. I have made a login here, and I can quickly use something called as a Innovia technology where I can quickly review the results, check where it is failing, and in the web browser only I can share that data to my other colleagues. So this is something called as a collaborative tool present inside the 3D experience environment, where if you want to collaborate with any of your colleagues, you don't need to go outside the this particular SolidWorks environment or SolidWorks ecosystem. This can be done here. Here you can see I'm raising a new issue where I'm telling that the thickness is not enough, which is causing the fatigue of it. In the same environment, I can attach the geometry. I can also tell the my colleague that this is the area where you need to focus on to make any design changes. I can even, if I want to add some geometrical data, like even if I want the like the snap what we created earlier to highlight him, this is the area. And at the end, the person who is going to make that design changes, or who is responsible for that design, I can tag him here. So once that is done, you can quickly see that issue has been created and it is being assigned to that particular member. Now let's see how Vaibhav will do the design changes. So let's understand a designer level simulation or the democratization or the changes how the Vaibhav can make in that same simulation. So this is a Vaibhav's environment, the same environment what I was using earlier. Now in this environment, what he will do, he'll get a notification on the top right that there is some design changes need to be made. You can quickly check on that particular notification window. Yeah, here it is. Here you can see he has quickly got a notification that there is some design issue with the boom geometry. You don't need to go anywhere to find where the issue is. Just need to click on that notification and it will open that particular window for me with that particular issue. The same issue management what I created is now able to now he is able to see on his particular screen all the description part, attachment, where it is failing. everything he's able to quickly visualize. Here you can also open the same geometry where you want to focus of what are the design changes to be needed to be done. That you can quickly visualize here. You can also even measure like what is the actual thickness Piyush geometry has. And at last, you can even address me like according to the given thing, yes, I'll make the design changes. Okay. So once he have addressed that I'm going to make the design changes, how he will do that part or how will reiterate to understand if he made any particular design changes, are those design changes viable or not? So we also have something called as the designer level simulation solution, where the focus would be only on the designer part. Like this is what a Weber's environment will look like again on the SOLIDWORKS part, where you can quickly open the whole geometry or probably only the single part, that is the initial boom part of it, as in a separate window. He can quickly make any design changes. Like he knows that how he has created the geometry. Like in the current scenario, you can see the thickness is 8 mm. What he'll do? Probably he'll change that to particular requirement. Like he want it to be 12 mm, 10 mm. So I'll skip a little. So once he made the design changes, he also want to understand whether the given design is good or not. So he can also have something called as a basic level simulation or a design level simulation, where he can quickly set up a quick simulation with a limited features, and which is very easy to use, very intuitive. Where you can see on the right, there is an assistant panel which can easily guide you how to perform a simulation. Like here, say define the clamp, here define the force, and he can quickly get a quick idea whether the given design is good or not. Like, is it going to be any particular challenges to him? So once he have felt that no, the given design, Piyush was right, the design is failing for the current scenario. What he can do, even he can perform something called as a parametric study, where any particular dimensions that were created in SolidWorks can be brought in 3D experience simulation, and those can be edited. Like here you can see the same dimension what we have captured in SolidWorks are brought back here, and I can quickly make a design changes here also. I don't need to go back to SolidWorks even to make those changes. Once I update the model, of course, 3D experience simulation, what it will do, it will open SolidWorks, make those design changes for you, and reflect those back in the 3D experience simulation app. Once that is done, of course, you don't need to again reset up the analysis. The already existed analysis can be reiterated either on local or on cloud to understand whether the given design changes has made any significant changes or not. So once that is done, he can then tell that the given issue that you mentioned is now being addressed out. The design changes has been made, and those will then put a notification to me that yeah, Vaibhav has done his part. Now it's again your part to check whether the updated design is good or not. So again, the design validation part comes to me, where one of the best thing is that since we are working in a collaborative environment on a single geometry, once he has done its part, I don't need to do anything. I just need to update the geometry and just rerun the same analysis. This this way, I don't need to even uh, like reset up the analysis or check whether he has created any different geometry where I need to redone the analysis. Even I can do something called as a comparison, where I can save the previous data and I can make a quick comparison about the design changes, whether how it has reflected to my result. Like the baseline design had a displacement of 8.26, while the revised one has the displacement has been reduced to 7.25. Even you can see the comparison of a one missile stress. Earlier it was around 362. Now it has been dropped down to below 250. Even the revised design has life above 7 log of life. So this way, we were able to set up the KPIs that were causing us the issue. The design of our current design is very validated, and it is being met our requirements. That is of course the log of life of 7, and the stresses is well below 250 MPa. Another thing that we talked about was something on with respect to perform a falling object, that is a FOPS. So how this can be done here? So this is a quick example where how this physical testing is done. So object is called, which is weighed around 227 kg from a height of 5 meters. To understand the roof present at the top of an operator, whether it's going to face any particular challenge or not. So you can see there is a person who is sit there, and there is a roof protector. So this is like a testing setup what you can see here. So this was one of the requirements where they want to understand if this setup can also be replicated on the 3D extension here, or 3D extension board. So again, the working environment or to do such type of analysis is very simple. We have created the same geometry here, since the geometry is axisymmetric in nature, sorry, symmetric in nature. We have taken the half of it, and we are just quickly setting up the analysis where we have created the geometry, defined the symmetric boundary condition, define a very special type of analysis called as explicit dynamic, which is very well known in the Abacus is actually very well known for the explicit solvers. Mesh, we have meshed it. You can see how beautiful the mesh looks on this particular geometry. And of course, once this is done, we can quickly run the analysis either on local. Of course, cloud would be a very, we can say, a best option to do such type of analysis. And once we run this analysis, you can quickly see how beautifully the drop test of that particular object on my roof. You can visualize how the effect it is going to, like even if it drop at the top end, how it is affecting the bottom or the right side of the cage. So a side by side comparison of the actual falling of the object as well as the same thing what we did on the 3D experience simulation. Interesting, na? Yeah. Same way, there is another approach where we can even do probably a top load or side load protection, that is a rollover protection simulation, to understand how much force it is required to buckle such cage geometry, or how much side load is required where it may perform get a significant failure at that particular point. So with this, we'll jump to the key takeaways that we saw today. I hope I made a good justice to your time that you have spent in today's webinar. Let's first understand what are the key takeaways. So I'll take the key takeaway in two aspects. Like we have some 3D experience simulation roles, some of the major roles. What we have something called as a structure mechanics engineer and durability mechanics engineer role, where we can easily create a simulation driven design, make a innovative product in accelerated method. You don't need to worry about the storage as well as the computing, since we are giving you a cloud storage or a cloud computing technology where you don't need to invest heavily in for a IT head. You know very well that if I want to do any particular analysis for in a given time, the requirement of a system configuration can be very high. So that is not a part here. You don't need to invest in a highly computing technology or a system. You can leverage our cloud computing as well as storage part for this. Of course, the main agenda for performing such analysis is to improve the quality, efficiency, or even reduce the cost to manufacture that product. With respect to the business value, of course, any businessman, it is important to reduce the IT cost, bring the product faster to the market, have a confident about the warranty that we are providing to the customer, and reduce the recalls that are coming due to some type of failures. So coming back to the presentation, the slide that we saw earlier, that how 3D experience simulation can help you. So this is where we are again reiterating. This solution is integrated in SolidWorks. It's a design-centric solution where you get a guided user interface. It's scalable, like you can start with a very basic role and upscale at any time requirement with respect to the type of physics that you want to perform. It has a basic to advanced type of simulation where according to the need of a customer or the level of a simulation that we need to perform, we can upscale upscale the analysis. Multiphysics, yeah, we do support multiple analysis where, let's say, if you want to do thermal analysis and those coupled to thermal stress, that is possible. At the end, of course, we talked a lot about cloud computing. So, of course, the main agenda is to reduce the IT cost of the cloud that is required even for storage as well for the computing of the analysis. With this, we are open for Q&A session. If you have particular questions, please write down your questions in the question option on the right side of your task pane. We are open for those particular to address those particular questions. So the first question we have is there any method that software gives any suggestion to our designer for improve the design? So any particular simulation software you come to the market, they work in a methodology where they will tell you whether your geometries pass or fail, but they won't give you a direct approach where they will tell make that particular design and your geometry may pass. Alternatively, there is an option here in the solutions in 3D experience simulation where you can create a multiple designs or tell the software, this is my design, these are my dimensions, and find out the optimum one for me. Yes, in that way, we can find which is the best design with respect to the dimensions that we provide and the limit for the provide. If I give a quick example, let's say there is a plate, same plate. Let's take the same plate what we saw in the earlier case where there was a cabin plate on the top. So it has a, let's say, thickness of earlier thickness of 5 mm or let's say 10 mm. With the simulation, I can perform a design automation where software can guide me what should be the optimum thickness of a plate, or in an alternative way, let's say if I create a stiffening plate below it, it can help me what should be the size of a stiffening plate where in an alternative or indirectly way, how many stiffening plates should be needed to get a good design which can sustain a given load. I hope I was able to address your question with respect to the improve the design. Yeah. Any other questions? Okay, I see there are no other questions right now from your end. Probably, let's say if you have any other questions, what we can do, we can connect back. Here is our particular details. So my name is Piyush Turi. I look after the technical part. I have my counter colleague, Mr. Soham Gap, who looks after the sales front. If you want any particular thing with respect to the commercial part, you can connect with him to understand more on the commercial part of it. Once again, thank you everyone for joining this particular webinar and spending your valuable time to understand the solution what we have integrated in SolidWorks and help you out for your design iterative and to get a cost-effective design. With this, I'll also thank my colleague Soham Gag for helping me out this particular webinar. Okay, so signing off, Tata, bye bye.